4 terabytes. Think about that for a second. That is the staggering amount of data a single autonomous vehicle is generating every single day. Between the cameras, the LiDAR, the radar, and all those sensors constantly running, a self-driving car isn't just a vehicle anymore. It is literally a massive moving data center. So you got to ask yourself a pretty critical question. Where does all that data actually go? I mean, how do we process this absolute mountain of information when a self-driving car has to make a life or death decision, like swerving to avoid a sudden obstacle, in just a fraction of a second? You absolutely cannot wait for all that data to travel across a wireless network, hit some distant server, process, and come all the way back. Welcome to The Explainer. Really thrilled to have you here. Today, we're diving straight into solving this modern data explosion dilemma. As we look at the tech landscape in 2026, with AI adoption totally everywhere and data volumes just exploding, we are looking at a heavyweight matchup: cloud versus edge computing. We're going to figure out exactly how modern systems process data to deliver the speed, the security, and the reliability that our world literally demands right now. Okay, here's our roadmap for today's explainer. First, the data explosion dilemma. Then, cloud versus edge defined. Next up, the self-driving use case. After that, training AI at the edge. Then, the hybrid tag team. And finally, your 2026 decision framework.
Let's kick things off with part 1, the data explosion dilemma.
Look, we are literally hitting the physical limitations of our digital world. Think about all the smart sensors, IoT devices, and high-def cameras out there. They're generating these massive raw datasets nonstop. If we try to send all of this to a centralized cloud, it instantly overwhelms our network bandwidth. It's just too much traffic for the pipes to handle. And worse than that, relying purely on the cloud creates some really dangerous latency. Even if you're on a great 5G network, a dropped connection, or even a slight delay, that's catastrophic for real-time operations. Throw in the rise in concerns around data privacy and security, and it becomes pretty clear. Sending absolutely everything away for processing is just a massive bottleneck. Which brings us to part 2, cloud versus edge defined. So I like to think of edge computing as the human body's instant reflex system. You touch a hot stove and your hand jerks away instantly, right? Your nerves process that locally. They don't send a message all the way to your brain to ask for permission. That's the edge. It's decentralized, it has ultra-low latency, and it's highly private because the data never actually leaves the device. Now, on the flip side, cloud computing is like your deep thinking brain. It lives in these massive remote data centers, offering virtually unlimited storage and the heavy-duty computational power you need for complex AI and enterprise analytics. So the foundational difference here really just comes down to geography. Edge computing processes data locally, right at the source, instead of shipping it off somewhere else. And why does this matter? Well, imagine a machine operating out in a remote location with super spotty internet. Edge computing ensures that machine doesn't just crash or freeze up. It keeps thinking and acting locally. Moving right along to part 3, the self-driving use case. There's this fantastic quote from NVIDIA's CEO, Jensen Huang, that I absolutely love. He says, "Cars are essentially supercomputers on wheels, and edge AI is what makes them intelligent enough to drive safely." I think that perfectly nails why edge computing isn't just a nice-to-have, it's absolutely non-negotiable for modern autonomous vehicles. A car simply cannot afford to be some dumb terminal just sitting there waiting for instructions from a cloud server miles away. And to act like a supercomputer, you obviously need supercomputer power. 254 trillion. That is the jaw-dropping number of operations per second being processed locally by advanced chips like NVIDIA's Drive Orin sitting right inside the vehicle. All this massive local processing power allows the car to instantly blend data from its cameras, its LiDAR, its radar, and create a complete, real-time 3D picture of everything around it. And here's the so what of it all. Here is why all that localized power is required. Braking decisions have to happen in under 100 milliseconds. Imagine a pedestrian unexpectedly stepping into the street. The car cannot afford even a 200 millisecond delay waiting for a cloud round trip, especially if the cellular network at that specific intersection happens to be congested. Processing at the edge ensures instant, fail-safe reactions, guaranteeing the vehicle stops in time, completely independent of whether it has an internet connection or not. All right, part 4, training AI at the edge. Now, usually, training machine learning models requires massive data sets, all centralized up in the cloud. But we know individual edge devices have limited computational power and memory, right? So what's the solution? It's called federated learning, and actually it's brilliant. Instead of taking raw, highly sensitive data like, say, video feeds of passengers in a car and sending all of that up to the cloud, the data stays completely private. It stays on device. The devices train a local model, and then they only share the learnings, just the model updates, with the central server. The server aggregates all those updates from the fleet and sends back a globally improved model. It's totally collaborative, but without ever compromising privacy. Which brings us to part 5, the hybrid tag team. So here's the reality for 2026. The real winner in this space isn't cloud or edge. The most innovative organizations are relying on a unified hybrid approach. You pair the instantaneous local response of the edge seamlessly with a massive global intelligence of the cloud. They're really just two halves of the same whole. So let's break down exactly how this hybrid tag team workflow operates in the real world. Step 1. The edge is your first line of defense. It pre-filters those massive raw data streams, throws out all the useless noise, and reacts instantly to any immediate threats. Step 2. The filtered, highly valuable data is then sent up to the cloud. The cloud takes on the heavy computational lift, running massive analytics, training new AI models, and analyzing long-term trends from across the entire fleet of devices. And then Step 3. The cloud updates the edge. It pushes those intelligent, newly trained model updates or even version rollbacks if needed back down to the devices, maintaining a reliable system across thousands of endpoints. Finally, let's wrap up with part 6, your 2026 decision framework. Consider this your ultimate cheat sheet for 2026. If your application requires sub 100 millisecond real-time responses, you absolutely must choose Edge. If it's not time-sensitive, cloud is totally fine. What about privacy? For highly sensitive data like PII, you want Edge. But for compliant central storage, cloud is your winner. For workloads, Edge handles the local compute beautifully. But if you have bursty, really heavy computational lifting, you need the cloud. Offline or low bandwidth environments demand the Edge, whereas always-on global access requires the cloud. And finally, scale. Localized action is Edge, but elastic, cross-device scaling, that's cloud. At the end of the day, most enterprises are going to mix and match these to build their perfect hybrid architecture. Whatever you do, don't get caught at 0% efficiency just because you forced the wrong architecture onto the wrong workload. Understanding this framework is absolutely critical for staying competitive. You need to evaluate your operational priorities, your data requirements, and your speed expectations today if you want to unlock long-term innovation. So, I want to leave you with this final provocative thought to take away. Is your business actually ready to embrace the immediate, intelligent reflexes of the edge, or are you risking it all by staying stuck exclusively in the cloud? It's time to evaluate your infrastructure. Thank you so much for joining me for this explainer. I hope you found it as fascinating as I did. Keep learning, and I'll see you next time.